In this lecture, we're going to introduce the NavMesh agent by having an AI unit follow some arbitrary transform. Let's get started. The NavMesh agent is a high-level component that interacts with the NavMesh to allow our AI units to move in the world. You can think of this like a player controller for your AI. It calculates a path to get to some destination. It controls the steering, which is just the direction and the speed, and it can even avoid other units. Let's hop over to Unity and check out some of those important configurations. In our project panel, if we come down to Units, Worker, and bring in the Worker prefab, this is basically just a model. There's not a lot going on here. Let's add the component, NavMeshAgent. We'll see in the scene view, we get a cylinder around the unit, and that's based on the obstacle avoidance. If we increase the radius, we'll see that gets larger. If we shrink it, it gets very small. Now, this is not a physics collider. It acts like a collider, in air quotes, for the navigation system and is used to find out where this agent can fit through and the radius that other agents will try to avoid. 0.5 radius looked like it was pretty good, so let's leave that there. The height is also how tall this unit is. For this game, since there's no overhangs or anything they need to walk under, that's not super important. The steering is how does this agent move? So this is how we can get some nice or not so nice feeling movement. Speed is 3.5 units per second, so they can move about this far from 0 to 3.5 in 1 second. The angular speed controls how quickly they can rotate while they're moving. So very slow values make you get a less accurate turn, and higher values allow us to get much faster and more responsive turns. Acceleration also plays a role in that turning. This is how quickly we can change our velocity. And we'll look at all of these in action in just a second. Let's go ahead and duplicate our worker, so we've got an extra one that we can play around with. Now for our first worker, we're going to need some way to send data to our NavMesh agent, so we can do things like set a destination for it. Down in our project panel in Scripts, Units, let's right-click, Create MonoBehavior Script, and for now, let's just call it Worker. Then we'll open that up in VS Code. Since we put this under the Units folder, let's make sure we update our namespace to include .units at the end. I don't think we're going to do anything on start, so we can remove that. And we are going to need a reference to the NavMesh agent. So let's add that on top with the private NavMesh agent. And because this worker requires that it has this, I'm going to say it requires it on the same object with an attribute attached to the class, required component, type of NavMesh agent. Then in a private void awake, we can do agent equals get component NavMesh agent. This is a pattern we're going to do very frequently throughout this course, saying that this mono behavior requires some types and we'll assign them on awake. This makes it where it's impossible to add a worker script to an object without it having a NavMesh agent, so we don't have to do a bunch of null checks later in case we messed up something. Now we also need a target for this agent to move to. Let's simply add a serialized private transform target. And let's just explicitly call our update function a private function. And in our update function, we can do if the target is not null, agent.setDestination to the target position. This means that every single frame, we're going to reset the destination of this NavMesh agent to wherever that target is. So our set destination requires a vector3 target position, and it'll return true if it was successfully requested. We don't really care if that happened in this case, so we can ignore that return value and just make sure that we're setting that destination every frame. Now, this can be a relatively expensive operation, so this isn't our ideal scenario here, but with only one unit, it's not going to be a big deal. With that, let's hop back over to Unity. We'll select one of our workers and attach our worker component. I'm going to assign the other worker as the target, and let's go ahead and click play. I'm going to pause the play mode because we see a lot of stuff is going on now. All of these white squares are indicating the avoidance. So we have this obstacle avoidance here, which is a little bit misnamed because it's really other NavMesh agent avoidance. And if you don't see this visualization like we talked about before, up here at the top of the scene view, you can click the AI navigation button, come into the agents section, and make sure that you have show avoidance turned on. We've also got all the other ones turned on, so if you want to make sure your scene is looking exactly the same as mine, make sure you check all of these. It wants to go in this direction, so this is the cone that it's trying to find other agents in, and it can tell that in this area, there's another NavMesh agent And now that's going to impact my velocity because I'm going to try to avoid that agent. We can see here this red line is the direction that they want to take, and this blue arrow is the direction they are taking because of this avoidance. We can also see this purple pinkish color with the bidirectional arrows saying that this is another agent and it may impact how this agent paths. We can also see this, orangish tan color, which is where our destination is currently set. If we deselect the agents, we don't see all that. When we select the other one, because this one's not moving, we only see that, hey, there's another agent nearby that I may consider if I get my destination set. Now, if we just unpause the game, we see a little bit of a problem here. This one agent is pushing the other agent because this worker is trying to set the destination to exactly where this one is. So that's causing a problem. One way that we can help prevent this happening is adjusting that stopping distance. The stopping distance is just how far away from our target destination can we be and consider that we still made it to that position. So we'll stop trying to move. We set the stopping distance in this case to 1, which happens to be our radius and their radius. Now this agent's like, hey, cool, I'm close enough. I don't need to keep pushing this other agent out of the way. Now, if we move the other agent, we can see how does a turning work. So we can see they're a little bit, rubber bandy or banding as they're turning, but they make a turn and eventually get moving in that direction. I'm going to select our NavMesh agent that's moving and click this little lock icon at the top right of the inspector so we can play around with this configuration while still moving this other agent. I'm going to lower the speed to 2 so they're a little bit less fast. And let's set the acceleration to something really low like 1. We'll see that it takes them a little bit of time now to start really getting going. If we set it to 100 for comparison, we'll see that they very quickly attain their max speed. Let's reset that to 8 and take a look at the angular speed. Let's set the angular speed to something really low like 8. Notice that this agent is taking a very long time to perform the rotation. Even by the time they make it to the destination, they're only halfway facing the right way. And that's where I'd like to introduce this lecture's challenge. For this challenge, I'd like you to adjust the configuration of the NavMesh agent so it feels more responsive when making turns. The tip is to try out multiple values and combinations of values until you're satisfied with the result. So go ahead, pause the video, play around with that agent steering configuration, and when you think you've got it working pretty well, go ahead and come back and let's take a look at it together. All right, welcome back. I hope you found some really interesting configurations and have a better understanding of how the angular speed, acceleration, and speed all work together. Now, I do feel like Unity has pretty good defaults with our steering with the speed. 3.5 is pretty good for a standard walking unit. Now, for our angular speed, remember the default was 120. So now I've got basically the default configuration, but the speed is a little bit slower. It's working okay, but they start moving and they're still facing the wrong direction. So what if we move this up to something like 720? Now this agent is turning significantly faster, and it doesn't feel like they're moving in the wrong direction when we're looking at them. The animation's obviously still off. We haven't hooked up the animator, but it feels more like they're moving in the direction that they're facing. Now, if we were to do something like increase the acceleration to, something like 32, we'll see that they pick up their speed a lot faster, but they start moving in that wrong direction sometimes because they're just not quite able to turn fast enough. So we can see as the acceleration increases, we will need to, I don't know if exponentially increase the angular speed is the right term, but we need to also really bump up the angular speed as well. So if I put the angular speed to something like 1440, now the agent is turning much faster, still a little bit off, but we might start getting the splitting hairs here. I kind of like the 720 angular speed, 8 acceleration for this unit, but there's not necessarily a right or wrong answer for this challenge. It was more of a learning exercise to see how do these all work together. Now, before we close out this lecture, we can't talk about the NavMesh agent without the obstacle avoidance priority and quality. We've been using the high quality avoidance, and we're going to use that for the vast majority of this course. But sometimes you don't want the agent to avoid other units, such as when they're gathering resources, you don't want them to have to bump around each other and avoid each other. You want them just to pass through one another. We can do that by setting the quality to none. But you'll notice that because one of them still has high quality avoidance, they don't pass through one another. So if we set both of their avoidance quality to none, we can suddenly move the agents inside one another. But even if only one of them has the avoidance turned on, we'll see that they start not being able to do that anymore. The different qualities affect how granularly and at what level of detail that they understand the world and the other agents around them. With the low quality, we can see that we only get this little star for the avoidance. It has many fewer data points to consider. If we bump this up to medium, you'll notice we get more fine-grained detection at the edge. At good, we get more data points in our star, and we get a lot more down here at the edge. And high quality you saw before, we've got many more fine-grained details. We've got some secondary map of detection in the middle. I found that in a lot of cases, using low quality doesn't dramatically impact the avoidance quality. But for our course, we're going to be primarily using high quality and none. Now for priority. The way priority works is agents with a lower priority can push units that have a higher priority, and they will not consider units with a higher number priority for avoidance. So they'll just steamroll right through them. Units only consider their same priority and lower numbers for their avoidance. Back over in Unity, if we set both of these agents to have the high quality obstacle avoidance, but we set one of them to have a higher priority than the other, we'll see that agent cannot push the other one. If we set them to have the same priority, then we can see that they can push one another. That's what we've been seeing this whole time. Now, if we flip it, where one of these units has the lower value, they'll start pushing the other agent and cannot be pushed by the other agent. This is really useful behavior when we have units that maybe tanks will push infantry out of the way. So you could set tanks to have a priority of 40 and infantry to have a priority of 50. I think that's a great stopping point for this lecture. So when you're ready, I'll see you on the next one.